Okay, we're going to evaluate this indefinite integral, which essentially means we're finding the antiderivative. The method that we're using for this section is the substitution method. And the substitution method is sort of like using the chain rule backwards. And what we look for, at least sometimes to get us going, is a composition. Sometimes it's not so clear, but here I'm going to let u equal the part underneath the radical. I'm going to see a composition of a radical, square root, and 1 minus x squared. So I'm going to at least try let u equal this. Now, it's also, I can, without really writing anything down, I can see the derivative of u, 1 minus x squared, is negative 2x. And the key is that I have that x sitting right there. Without that x sitting there, I would have to do the problem very differently, and it wouldn't be in this section. So now what I do is once I have u, I sort of just follow the steps where I take the derivative of u, and that's just going to be 1 times du. On the right-hand side, 1 minus x squared, I take the derivative, negative 2x dx. And the way I do this, and also the author of the book, I divide both sides by negative 2, so that I have on the right-hand side only an expression with x's. I don't mix the x with the u. Do not divide both sides by negative 2x, regardless of who tries to talk you into doing that. Do not do that. It's not what we're supposed to do. All right. Now, looks like things are coming along. What we can do is, if we feel like it, we can do this one little extra step where I place the x right next to the dx, so I can really see what's going on in terms of that substitution. That x dx is negative 1/2 du. I just simply replace x dx by negative 1/2 du. I'm going to replace 1 minus x squared by u. Notice I changed the radical into raising to the half power. Okay, now, so this all becomes integral u to the 1/2 times negative 1/2 du. I like to usually bring the negative 1/2 outside of the integral, just to sort of, I don't know, just to make it look nice, and also just, it looks more organized, and I think I'm less likely to make a mistake or get confused. So I bring the negative 1/2 to the front. Now I integrate, which when I say integrate, what I mean is I'm going to find the antiderivative. So I have negative 1/2. The antiderivative of u to the 1/2 is found by adding u to the 1/2. I add 1 to a half, and I get 3/2. Then I divide by 3/2, and it's plus c. Why plus c? Because I don't have bounds of integration. And then next, I'll do two things. I'm going to multiply by the reciprocal of the denominator 3/2, and I'm going to replace u by what it's equal to in terms of x, so 1 minus x squared. And that's almost there. I'll just do a little simplifying with canceling over here. I want to save a little bit of space. Okay, so this is equal to negative 1/3 1 minus x squared to the 3/2. Now, if you have time and energy, what you can do is you can take the derivative of this guy here, this answer, this antiderivative, take the derivative and see if that you get x radical 1 minus x squared. That's what you should get if you take the derivative of what our answer is there. We should get our original integrand, x radical 1 minus x squared. Any comments, questions, or comments on that? Okay, let's do another one, maybe that I think is more. Here's a bunch of solutions, but let me do number 21, because that's a good one, in my opinion. Okay, this is section 5.5. And now it just seems to me, whenever you have ln x in these integral problems, like a lot of the times, pretty often, that's going to be your u. Same if you see like arctangent, that's going to be your u also. But anyway, let u equal ln x. And once we get that, everything should follow sort of easily. And by the way, I think it's like a trick, or not a technique, just a technique might be that whenever you see a fraction, when you're integrating, not whenever, but you might want to break that up as the numerator times 1 over the denominator, and you can start seeing some things. And especially what I see is that when I take the derivative u, I get du, and then for derivative ln(x), I get 1 over x dx. Well, what do I see? I see that 1 over x is sitting right over here. 1 over x dx is sitting here, and that's du. Then ln x is u. So this whole thing is equal to the integral of u squared du, which is an easy integral using the power rule. I have u squared, I take 2 plus 1 and get 3. And so therefore, let me write 1/3 times u to the third, and u to the third is going to be ln x to the third. Notice this is not ln parentheses x cubed. This is parentheses ln x, all of that cubed. So that's that one. And should we do one more? Okay, let's check out number 23. So that's 21. Are there any comments or anything you want to talk about on that? Let's check out number 23. The key is often when you're trying to decide what u is, you think ahead and start thinking, hold on, what will du be? So sometimes you can sort of work ahead by thinking of what u should be. And what I see in this, what sort of stands out in this integral right here, this problem number 23, integral secant squared theta, tangent theta, third power, what I see and think about is, well, hold on, isn't secant squared theta the derivative of one of the trig functions? Yes, it is. What's it the derivative of? So u equals something. If I want du equal to secant squared theta d theta, what would u be? Well, u would be tangent theta. The derivative of tangent theta is secant squared theta. So sometimes you can sort of determine or think about what u should be by looking ahead and saying, oh, well, I see secant squared theta, I see the derivative. So, you know, if u is tangent theta, du is secant squared theta. And so now I just directly substitute. Tangent theta is u, and secant squared theta is du. Another thing that I sometimes do to explain at least is these problems is to, when I see a trig function raised to a power, I put parentheses around the trig function like I did here. I have tangent theta parentheses to the third power. Then that helps, I think, maybe for people to see that that's a composition of functions. So this becomes a very, you know, sort of elementary integral then. And u is tangent theta, and I raise it to the fourth power plus c. Anything you'd like to talk about on that one? Any questions or comments? Okay, so therefore, let's see, I have these two problems, 21 and 23. I can't really zoom out and get the other one that we did before, but I have, I did another one on this video also anyway, but here we have two problems. So let's go ahead and stop the video for now.